Okay, so hey everyone, in this video we'll be actually looking on the optimized version, like optimized code version of the Gardener entry. The previous one which I uploaded actually got a failed system test as the question had a bit tight constraints. So in this question the implementation is a bit simpler and we'll be using standard BFS. So I'll just explain once. So the main idea behind this question is just consider the uh, trees something to look like this: 1 2 3, then here we have 4, a 5, and let's just say here we have 11, then a 12, then a 16, and then here we have 18. Okay, so first what we have to actually assign is कि नीचे से depth कितना है. Like for example, what I mean by depth is how close that node is to the ground. For example, इसका यहाँ पे होगा 0, all the leaf nodes would be 0 basically. Basically they will be the reference points. तो यहाँ 0, ये 0 होगा, तो यहाँ पे 0, these all would be 0. Then using standard BFS we'll be updating the depths of 1 2 3 4 5 and 12. For example, the depth of 12 would be 1. Now when it comes to 4, you'll have two options: either it will be 1, like you have an option of 1, or it will be 2, like depth from here, the depth of here is 2 and the depth from this node is 1. So what should we consider? We have to actually consider the maximum one, because that actually means that only after you remove the nodes from depth. Okay, so if I consider its depth as 1, just say I consider this as 1, so that means that if you remove this, the depth also represents that how many nodes you have to remove. Like listen closely, how many nodes you have to remove such that that particular node becomes a leaf. कितने nodes हटाने पड़ेंगे उस node से connected so that that particular node becomes a leaf, ताकि वो node leaf बन जाए. So जैसे सारे लीफ नोड का तो ज़ीरो, क्योंकि वो ऑलरेडी लीफ है, यू डोंट नीड टू रिमूव एनीथिंग सो दैट दे बिकम लीफ. बट फॉर 4, इफ आई राइट ओवर हियर 1, दैट मीन्स दैट इफ यू रिमूव दिस शुड बिकम अ लीफ. But that's not the case. So to make sure, you always have to take the maximum one. Like if you have two options, 1 and 2, you always have to consider the second one, because by the time this is disconnected, this is disconnected, this will obviously be disconnected, and then only you can call this thing as a leaf. So you always have to take the maximum distance from the ground. Like if you have this option and this option, you have to consider the maximum one, because the maximum one is actually the number of nodes you have to remove to make that thing as a leaf. And I'm considering these two as in same level. So if the answer is 2, like first you'll be removing this, so both 0 are disconnected, then 1 is disconnected, so the answer is finally 2. So you always have to consider the maximum distance 2 from the ground. Okay, so is यहाँ पे we'll write 2 again. What we'll be writing here, either we have the option of 0, like we can put this as 1, or we can put this as 3. Why 3? Because this thing 4, 12 and 16, so 3 of, so again we have to consider the maximum one. So here we have taken 3, here 0, and then here 4. Okay, after, like we'll be making a depth array for this, we'll be actually making a depth array for this thing, and after that you just have to run a simple loop and check that who all have a depth, who all, like for example, who all have a depth of I greater than equal to k. For example, greater than equal to k, you have to make your count plus plus. Now what is this thing? For example, the k given to you is 2, so all the 0 depth would be removed, 0 would be removed, 16 would be removed, 5 would be removed, and 3 would be removed. Then all the 1 distance would be removed, this 12 would be removed. Then all the left out would be greater than equal to k, like they are far away from the depth, they are far away from the leaf node. Like this is 2, like this is 2 distant, this 4 node is 2 distance from the leaf node, like it's far away from the leaf node, like we don't have enough operations to reach the 4th node. Therefore all the nodes which have a depth I greater than equal to k are the safe nodes. So the count of safe nodes, you will do plus plus whenever you find depth I is greater than equal to k. Okay, so we'll be coding this along. So I have taken the input, I guess. Okay, so what all do we have here? First we have the nodes. nodes, and then we actually have the k, then c in nodes k. Then the number of edges would be obviously nodes minus 1 in case of tree. Let's make a graph, dj of nodes plus 1, and we also need a in degree count, in degree of nodes plus 1. Then again, as I said, we need a depth count, so a depth count. Then let's just take the input for ll I is equals to 1, I less than equal to hs, I plus plus. We'll take ll x comma y, c in x y, then adj of x dot pushback y, adj of y dot pushback x, and then we'll also increase the in degree of x plus plus, in degree of y plus plus. Okay, so we are done with this. Now then let's just assign who all have the depth as 0, like, and just push them into a queue. So basically we'll be using standard BFS search, so you can just refer how to perform a BFS search. So we'll take a queue, ql, then we'll be going over all the nodes. ll I is equals to 1, I less than equal to nodes, less than equal to nodes, I plus plus. If the in degree of this node equals 1, like the in degree of 11, 16, 18 would always be 1. So then just push it into that thing, q dot push I, depth is already made equal to 0, so we don't need that. Then after this thing, depth is already set. Now we'll be performing a simple DFS search, q dot empty. Then we'll take what we have as front, llu equals to q dot front. Then you'll just simply pop that, q dot pop. Then we'll traverse to its adjacents for auto, ad of adj u. And then if you find anything which has already, like for example, for just say you'll be traversing on 12, then I know, मतलब भले 16 जो है, you have that as the adjacent, but you won't be taking that into consideration because that has already been taken care of, that's already in the queue. So if the in degree of your adjacent is already less than equal to 1, just simply continue. ये basically वैसा ही है जो हम visited लगाते हैं ना, this is that same case that you don't have to visit a certain node twice. Then you have to reduce the in degree of this node, in degree of ad minus minus. Now अभी हमें depth set करना है, so depth of ad is equals to max of depth of ad comma जहाँ से हम आए हैं u से, depth of u प्लस 1. ये क्या किया हमने, फॉर एग्जांपल जैसे हम लोग 4 पे ट्रेवर्स कर रहे हैं, तो एक टाइम आएगा जब हम 11 से वहाँ पे जाएंगे, 11 से जब हम वहाँ जा रहे होंगे हम हमारा डेप्थ 1 सेट कर देंगे. फिर एक टाइम होगा जब हम 16 से 12 और 12 से 4 जा रहे होंगे, तब हम क्या रखेंगे, डेप्थ ऑफ 4 इज़ मैक्सिमम ऑफ 1, जो उसका 11 ने सेट कर दिया था, कॉमा ये लेके जा रहा होगा उसके पास 2, तो हम मैक्सिमम सेट करेंगे. मैक्सिमम क्यों सेट करेंगे वो अभी भी एक्सप्लेन किया. सो ये 2, सो उसका डेप्थ मैक्सिमम में सेट हो गया. नाउ अगर वो चीज़ अभी लीफ नोड बन गई है, इफ़ दैट थिंग इज़ नाउ अ लीफ नोड, यू अगेन हैव टू पुश इट ऑन द, लाइक पुश इट इनसाइड द क्यू डॉट पुश ad. ठीक है, लेट्स जस्ट से कुछ एरर है क्या, इफ इट कंपाइल्स और नॉट, शुड कंपाइल 5.8 2.4. ठीक है, देखते हैं. नाउ एक सेफ नोड का काउंट रखते हैं, ll सेफ नोड्स जो 0 फॉर ll I इज इक्वल्स टू 1, I लेस देन इक्वल्स टू नोड्स I प्लस प्लस. इसका होगा सेफ नोड्स प्लस इक्वल टू दैट डेप्थ ऑफ दैट पर्टिकुलर नोड इज़ ग्रेटर देन इक्वल टू दैट k जो हमें दिया हुआ है. Then let's just see out safe nodes and l 700312 700,312. Okay, let's try submitting this. gardener entry, submit. This should run. Okay, so it got accepted. So हाँ, ये था इसका code. Thank you, and I'll put this code in the description section. Thank you.